Let's go to page 97 and number 156. Okay, so you have 4 to the 8 plus 6 to the 8 plus 9 to the 8. You want to find two numbers that will multiply, the product will equal to that. So basically you want to find out what this can factor into 2. So you want to factor this into two factors. So when this factor into two factors, then that will give you the two numbers multiply, give you this number. But before we do that, let's go ahead and try to tidy these things up a little bit. So 4 equal to 2 squared, and 6 equal to 2 times 3, and 9 equal to 3 squared. And so simplify things a little bit. So this equal to 2 to the 16 plus 2 to the 8, 3 to the 8 plus 3 to the 16. Okay. And from the identities, okay, remember that a squared plus b squared equal to a plus b squared minus 2ab, or this is also equal to a minus b squared plus 2ab. Okay. So these will equal to this will be more like this one here. Okay. So if you were to this will equal to 2 to the 8 plus 3 to the 8 squares. When you square, you're going to plus 2 of these. You're going to get plus 2 of the middle term. So you have to minus a middle term to match that. So again, if you notice the square, you're going to get 2 of these. Okay, but you only got 1, right? So you have to minus 1 time to compensate for that. Okay. And so from here, you can make into difference of square. So it'd be the first. So that's the first minus the second. Run out of space. So minus 2 to the 4, 3 to the 4. So that's your first parentheses. And second parenthesis would be 2 to the 8. So again, so this is like a and a b, right? So this is like your b squared. And so this would be 2 to the 8 plus 3 to the 8 minus 2 to the 4, 3 to the 4. Okay, so now you can go and work this part out. So you're going to get A113, and this one you work it out, you get 5521. So in other words, so this is a product of these two. So basically, it's just a basic factoring, so a little bit challenging. Okay. So number 157. You have an n cubed minus n. And what is the largest number by which this is divisible by all possible integral value of n? So again, first let's go and factor out the n. So you get n squared minus 1. And then you go ahead and factor into conjugates. So you're going to get n plus 1, n minus 1. Now if you rearrange these, okay, in the correct order, you actually in the increasing order, so you got n minus 1, n, and n plus 1. So this number, so this is the product of the 3 consecutive numbers. Okay. Okay. So notice that it doesn't matter what n is. One of these is going to be an even number. Okay. So this again so this is the 3 consecutive numbers. So that means at least one of the numbers is going to be even. Okay. So at least one of it is going to be even. That means it's divisible by 2. Okay. And because you got 3 consecutive numbers, that means it will always divisible by 3. Okay. So again, because 3 consecutive numbers, you can give an example, you know, like, I don't know, try 4, 5, 6, okay, for example. Okay. So again, you see that at least one of them is an even number. And also, when you have 3 consecutive numbers, it's always divisible by 3. Okay? Because when you add the numbers together, it will always be the multiple of 3. Again, you can try other numbers. Okay? Try, for example, like 7, 8, 9. Okay? Again, you're going to have at least one even number. And when you add 3 digits together, it will always multiple of 3. So this is always divisible by 2 and divisible by 3. Other than that, we cannot tell anything else. And because it's divisible by 2 and divisible by 3, therefore it must divisible by 6. Okay? And so that's all we can conclude. It's divisible by 6. Okay? Okay, let's go to 158. It says find all the positive values of a, b, giving that a plus b equal to 2, and a to the 4 plus b to the 4 equal to 16. Okay, so again, this is fairly standard problem. So let's go ahead and square this and see what we get. Okay, we want to get that. So a plus b equal to 2. You square both sides. So you got a squared plus b squared plus 2ab equal to 4. And we can move this over. So a squared plus b squared equal to 4 minus 2ab. And so far it doesn't help us too much yet. So, but to evaluate, we need to get the fourth power. So let's go and square this again. So a squared plus b squared. Again, write it one more time so you don't mess that up, so you can keep track of what you're doing. So go and square both sides. So you get a to the 4 plus b to the 4 plus 2a squared b squared is equal to 16 plus 4a squared b squared minus 16ab. Okay, so this part over here, we know that this is equal to 16. Okay, so you got 16 plus 2. This one, I'm going to move this over. Okay, let's go and do that. And minus 2a squared b squared minus 2a squared b squared. Okay. And so this came from here is 16, so equal to 16 plus 2a squared b squared minus 16ab. Now the 16 cancel out, so minus 16 minus 16. So you got 0 equal to 2a squared b squared minus 16ab. Well, it's kind of turned out nice because it's factorable. But before we do that, let's go and divide by 2 to lower number. So 0 equal to a squared b squared minus 8ab. Then we can factor out the ab. And so from here you can see that ab is equal to 0 or ab equal to 8. Okay, let's go to 159. You got a cubed minus b cubed equal to 24, a minus b equal to 2, and you're looking for a plus b. Okay, so for this one we actually can do some factoring, okay? But since this is more about kind of cube and square and all that, so let's do the cubing then. Okay, so a minus b from here equal to 2, and so we're going to cube both sides. So I get a cubed, so again, when you have a minus, remember it's alternate, right? Plus, minus, right? So minus 3 a squared b plus 3a b squared minus, so plus minus b cubed equal to 8. And we can collect this over here. So a cubed minus b cubed, and this part over here, you can factor the 3ab. So you're going to get a minus b equal to 8. Okay, so again, this 2 is this 2 over here, and this over here, factor the 3ab, you get a minus b. Okay, and this one we know, a cubed minus b cubed is 24. So substitute, so 24 minus 3ab, and we also know that a minus b equal to 2. Okay, so minus 24, negative 6ab. You know, that's not multiplied because we're going to divide anyway. So 3ab times 2 to 1 step at a time, so negative 16. Then we're going to divide by negative 2, so 3ab equal to 8, so ab equal to 8 over 3. So that's kind of, it's going to help a little bit, okay? Now, so once we find ab equal to 8 over 3, now we also can use this, because to get these, we need to kind of go backwards. So do the a plus b. We don't know what is equal to yet, and so that's going to square that. This will give you a squared plus b squared, okay, plus 2ab. Okay, and so if we know what this equal to, then we can find the a plus b. We can just kind of go backward and take the square root. So we don't know what this is equal to yet. We know what this is. Okay, so to find these, okay, we can go off to the side. We have to use these. So a minus b equal to 2. You square both sides. So you get a squared plus b squared minus 2ab equal to 4. Okay, and we know what this is. Okay, so a squared plus b squared minus 2ab is 8 over 3. Okay, so a squared plus b squared will equal to 4 plus 16 over 3. So move this over. So a squared plus b squared will equal to 28 over 3. Okay, so now we know this part we can substitute into here, and this part we can substitute. So a plus b squared equal to 28 over 3 plus 2 times 8 over 3. So a plus b squared equal to 44 over 3. Okay, so now we can go ahead and take the square root. So a plus b equal to plus or minus square root of 44 over 3. So a plus b equal to plus or minus 2 square root of 11 over square root of 3. So a plus b equal to plus or minus 2 square root of 33 over 3. Okay, let's go to number 160. You want to find all the prime factors of 3 to the 18 minus 2 to the 18. Okay, so let's going to use the difference of square. So you're going to get 3 to the 9 plus 2 to the 9, and you got 3 to the 9 minus 2 to the 9. Then after that, I'm going to do the cube. Okay, so before we do that, it's going to make it into the cube form. And I'm going to move this over to give me a little bit space in between. So do the same thing, 3 cube minus 2 cube to the cube. Okay, so to factor this, you just get rid of the cube, right? So you're going to get 3 to the cube plus 2 to the cube. In the bigger parentheses, you have to square this. And the middle term is the opposite of these. And this would be plus 2 to the 6th power. Okay, and the same thing over here. This will give you 3 cubed minus 2 cubed, and the bigger parenthesis, you square that, and the middle term is opposite, so plus 3 cubed, 2 cubed, and plus 2 to the 6. Okay, so now this is also still factorable, okay, because this is the cube, and this is also the cube, okay. But I think at this point it's probably easier to just go and work it out, okay. So just go and work it out because number is much easier to deal with than the exponents. Now, if the exponents are super high, like this over here, then it's very difficult to work it out first. But over here, this is not too bad, okay? So you can actually work it out. Okay, so this one you get 27 plus 8, so you get 35. And this one, you get 577. And this one you get 27 minus 8, so you get 19. And this one you get 1009. And this one is still factorable, so you get 5 times 7. And I'm going to rearrange. Okay, so those are your 5 factors. Now, one thing you have to watch is this. Let's say, those are your answer. Now the word of caution is if you do it this way, okay, if you do the cube technique, okay, so notice this is a sum of the cubes. So you can go and factor into 3 plus 2, and you're going to get 3 squared minus 3 times 2 plus 2 squared, okay. So this is this. And this one will give you 577. Now this one, when you do the cube, when you're doing the factoring the cube, right, and you're going to get 3 minus 2, and you're going to get 3 squared plus 3 times 2 plus 2 squared. And this big parentheses over here is 1009, okay. The point I want to emphasize is this part of it. So you're going to get 5, and this one you're going to get 9 minus 6 is 3, plus 4 is 7. And this is 577. This one you get 1, okay, and this part over here, you're going to get 9 plus 6 is 15, plus 4 is 19, okay. And now, if you do it this way, this is not your answer because this is not a prime, right? It says ask for all the prime. So if you box that, then you're going to get it wrong, okay? So you can watch out for that. They always have to sneak in there with 1. Again, 1 is not a prime. So in this case, you have to kind of forget about that one, okay? Again, 1 is a prime. So it says all the prime factors. So this is not a prime, so do not include that. So your answer would be 5, 7, 19, 577, and 1009, okay? Which is the same answer as these, okay? So just be careful with that. Again, they like to sneak 1 in there. Remember, 1 is not a prime number. It's neither, okay? So just watch for that. Okay. Let's go to 161. It says if Q is an integer, they can express it as a sum of 2 integral squares. So that means a squared plus b squared. Okay. You want to show that 2q and 5q can also express as sum of the 2 squares. Okay, so q equal to that, so 2q will equal to 2 times that, so equal to 2a squared plus 2b squared. And you want to express this as a sum of the 2 squares, okay? And the clue is this, okay? The 2, see 2 is equal to 1 square plus 1 square. Okay, so that means you want to start out as the two squares. So you're going to get 1 and 1. So you're going to get a plus b. So one power and 1 power. Okay, and to square that, and you want to add this square. So you can see when you do that, you're going to get a squared plus b squared. See that? So again, you have coefficient of 1 and 1. When you square, you're going to get 1 and 1. And plus 2ab. And this part over here, you're going to get a squared plus b squared minus 2ab. Okay, so you need to get the plus and minus so that this will cancel out. So when you do that, you can see that you got 1 square and 1 square. See, so coefficient is 1 square plus 1 square give you 2, right? So when you do that, you're going to get 2a squared plus 2b squared. Okay, so this is equal to that. So because it's kind of hard to see that in the beginnings, but when you do that, you can see the equal to that, right? So you can see that 2q equal to this, right? You can see that this is equal to that. So it's equal to a plus b squared plus a minus b squared. Okay, so again 2q equal to sum of the two perfect squares. And you're going to use the same technique for the 5. Okay, so 5q will equal to 5a squared plus 5b squared. So you have to think, okay, now what's the sum of the two square give you 5? Okay, well, realize that 5 equal to 2 square plus 1 square, or if you switch the coefficient, you get 1 square plus 2 square. Okay, so in this case, okay, you want to try 2a plus b square plus a minus 2b square. Again, you want to try the coefficient of 2 and 1. Okay, so 2 and 1. Okay, you also, for the 1 and 2, you actually can also try the conjugate. Okay, so you can try 2a minus b square plus a plus 2b. So now we're the conjugate of these. Okay. So again, if you try that, if you work it out, you're going to get 4a squared plus b squared plus 4ab, and this one you're going to get a squared plus 4b squared minus 4ab. Notice this one will cancel out. Okay, so you end up equal to 5a squared plus 5b squared. Okay, and that's what we have, right? See this over here? So if you go backward, this will equal to that. So now the 5q equal to that. So equal to 2a plus b squared plus a minus 2b squared. Okay, again, so 5q will equal to sum of the two perfect squares. Okay, whatever that is. Now, when you try this, you're going to work out exactly the same way. Okay, so you're going to get 4a squared plus b squared minus 4ab, and it's just going to reverse of that, right? Plus, oh, forgot a square over here. And plus, you're going to get a squared plus 4b squared plus 4ab. Again, plus 4ab and minus 4ab will cancel out. So this is equal to 5a squared plus 5b squared. Okay, so you can say, right? So that means this is also equal to that. So you can see that 5q will equal to 2a minus b squared plus a plus 2a minus b, a plus 2b squared. And again, if you notice, they are conjugates, right? Okay. And again, the things to notice is the 5. 5 is 2 squared plus 1 squared. So you need to get 2 squared, the coefficient. 2 squared and 1 squared, and 1 squared and 2 squared, right? Okay. And because it's square, it can be plus or minus, right? And so that's it.